we are going to talk about in this section is significant digits. You do this in your science classes sometimes. I think we have slightly different rules on, hey, I'm ready now, so side conversation stop. We have slightly different rules on a few things. One of the big ones, we don't round until the very end, so I know sometimes, like, I've been told that in some of your science classes, like, you round multiple times within the problem, and we will not ever do that. We only round once at the very end. But when we count significant digits, the rule is you start with the first non-zero digit on the left, and then count that and everything after it. If there is a decimal point, then you count trailing zeros, so zeros on the end. But if there is not a decimal point, we do not include those zeros. It involves a lot of extra rounding, and then your answers are not always as accurate. But it is a good concept. You know, your answer can't be any more accurate than the original numbers you started with. If I gave you some figures and I rounded everything to 1 decimal point, then is your answer truly accurate to 4 decimal points? No, because your original numbers weren't that precise. So we will use these rules today, like in this section, we're going to follow these rules. And then after this, I will specifically say in the problem, round your answer using significant digits when I want you to. So we won't do it on every problem, but we will periodically. Let's start just making sure we can count significant digits. So we start with the first non-zero digit on the left. So my first non-zero digit is non-zero digit 4. And then we count that and everything after it. So this one only has 2 significant digits.
Ask to the left, you meant the whole number from the decimal point. You say yes. That's the right.
Well, it depends on where it is. Like, you start on the left-hand side. So
Okay,
I start over here, and I go until I find one that's not 0. All right, B. So starting on the left, my first non-zero digit is 2. And we have a 0 and a 5. So this one has 3 significant digits. C, how many would it have? We have the 6. If there is a decimal, we get to count these zeros. If there's not a decimal, we don't count zeros. So because we have a decimal place, we count them. So this has 4 significant digits. So I count everything. So there would be 5. On E, there is only 1 because we have no decimal place. So we only get to count that first digit. All right. Any questions here? So from now on, we are going to make some assumptions when we're solving our problems. When I say triangle ABC, I'm probably going to quit saying where angle C is the right angle. Just assume it. So anytime I say triangle ABC, we will just assume that angle C is where our right angle occurs, unless you are specifically told otherwise. If we are using significant digits, we round our answer so that the number of significant digits in our answer matches the smallest number of significant digits given to us. So I might give you 3 different numbers, and one might have 2 significant digits, one might have 3, one might have 4. Your answer has to match the smallest. So your answer, you would only be able to do 2 significant digits. And the final step, probably the single most important, don't round until the very end. Because every time you round, it throws off your answer just a little bit. So what we're going to do now is start solving triangles. When I ask you to solve a triangle, you have to find every measurement in the triangle. So that means every angle and every side. Up until now, we've done several problems with solving for sides of triangles, but we haven't ever had to find the angles. So let's take a look. If I were you, I would probably just draw the picture instead of trying to write the words. So we have right triangle ABC. And I've told you, if I don't tell you otherwise, your right angle is C. Okay, angle A is 40 degrees. One problem I noticed on the quiz, a few of you were flipping, not putting your sides in the correct spot. Remember, side A is across from angle A. Side B goes across from angle B. And it told me that my side C was 12.
Does it matter, like, when we're drawing this triangle, if we put A on the top where the B is right now, as long as we put our,
As long as you
our
move the
adjacents,
sides as well, yep.
or our opposites.
Yep, so if you move angle A to the bottom, then side A will go opposite it. All right, we need to find side A, side B, and angle B. Probably the easiest thing here is angle B. How do we get that?
Add them up and then subtract one.
We know in a triangle all the angles always add up to 180. So if this is 90, 180 minus 90 is 90. 90 minus 40? 50. Do I need to write down how I got that? Now the sides are a little bit different. Make sure you put an angle measure on that, so a degree. So if I wanted to find side A, I know angle A. Side A is opposite. The side I was given, 12, was my hypotenuse. What trig function involves opposite and hypotenuse? So the sine of 40 degrees equals the opposite side A over the hypotenuse 12. Now we've done these, but the angle is always one that we had from our hand trick. 30, 45, 60. Do we know 40? No, so we are going to use our calculator, but not until the very end. So if I want to get A by itself, what would I do? So make sure your calculator is in degree mode. And we want to type in 12 times the sine of 40.
We don't round here.
Yeah. So we get a number that looks like this. Did everybody get that? If I want to answer with significant digits, my general rule is let's make sure all the angles have the same number of significant digits and all the sides have the same. My one side was 12. How many significant digits is that? 2. So let's round this to 2 significant digits. 7.7. Do we have a unit?
No. Centimeters.
Okay. Now here's my next word of warning. Depending on how you continue this problem, there is potential that in some situations your answer for side B might be slightly off. Here's why. Is 7.7 a very accurate number? No. So if you, for instance, try to do Pythagorean theorem with 7.7, are you going to be completely accurate?
No.
No. If you use the 7.71345, it would be better. A lot of times what I do is just try to go back to the original and use the numbers given to me as much as I can. So if I wanted to find side B using the numbers given, what would we do? So if we multiply over the 12, side B is 12 cosine of 40. And again, it's a side. We're doing 2 significant digits, so this would round to 1.2 centimeters. Okay. So what I ask of you, if at all possible, try to use the numbers given in your problem to reduce your rounding error. But if you have to use one of your earlier numbers, please show me the work so I know how you're doing it. Your answer is not going to be off by much, but there is potential you might have gotten 9.1 instead of 9.2. And I need to know how you got that, so as long as it's accurate for your rounded numbers you were using, you would get the credit for it. but I just need to know how you're getting your answers. Does that make sense? All right, so I have lots of examples of these. Let's do at least one more like this. How about, might kind of skip around here. Let's do this one. Now, if one of your angles is in degrees and minutes, then I expect the others to be in degrees and minutes. So I don't want some degrees and minutes and some decimals. Give me all the same. We know we're talking about triangle ABC. So side A is across from angle A. Angle B is 26 degrees, 30 minutes. The side opposite that is 324. So I need angle A, side A, and side C. How can I get angle A?
Make it into decimals.
Let's keep degrees. Okay, that would give me side A. Let's go ahead and do that then. So if you want side A from this angle, it's adjacent. But what is this side? Opposite. We could do cotangent or tangent, yeah. If we're ultimately going to use our calculator, which button would be easier, or which one would be easier? Tangent, if we're going to have to use the calculator. So we could say that tangent 26 degrees, 30 minutes equals my opposite side, 324, over my adjacent side, A. So if you're solving this, to get rid of the fraction, you have to multiply the A over. So then to get A by itself, you would divide. Okay, so remember when you're typing that in, you have 324 divided by tangent, and you do 26 plus 30 over 60. And we get 649.8434. You guys get that? So how many significant digits do we need? 3. Okay, so 3 is 649, but we can't just cut it off. The 8 tells us we would
Do 650.
round up to 650. Now, how many significant digits does 650 have? 3. Does it?
2.
It only has
There's
2
no
because
decimal.
there's no decimal. It's okay sometimes due to the fact that you might have to round. It might have fewer significant digits. You just can't do more. So this would be 650 millimeters.
But we can't have decimals because that means
Right. Okay. If I wanted side C and I wanted to use these numbers, okay, we could say the sine of 26 degrees, 30 minutes equals the opposite, 324, over the hypotenuse, which is C. So if you want to get C by, or get rid of the fraction, you have to multiply the C over, and then we have to divide. So we get 324 divided by the sine of 26 plus 30 over 60. If we round to 3 significant digits, what would it be?
72 cents.
I'm also missing an angle. I've told you can assume that C is 90 degrees, but we need to find A. If your triangle triangle adds up to 180. And one of those angles is 90. What did the other two angles add up to? 90. So couldn't I just do 90 minus 26 degrees, 30 minutes? Okay, so this would be 89 degrees, 60 minutes. So 89 minus 26, and 60 minus 30. And that was angle A. Any questions on that? Let's look at this problem. So we have right triangle ABC. Side A is 2.73. Side B is 3.41. Find the remaining sides and angles. Use degrees and minutes for the
Don't we have to A, capital A, capital B, capital B?
Not necessarily.
Do we have to go in and convert the decimals into degrees and minutes?
No, because those are sides, not angles. We don't have any of our angles.
So angles are in degrees minutes, and then
Sides
sides are
don't
just
have any.
regular.
Right.
Okay.
Yes, Carson?
Do we find the tangent and then do the tangent negative?
That would work. So if I wanted, let's say I wanted to get angle A. Okay, I have the opposite and the adjacent sides. What trig function involves opposite and adjacent? So we can say the tangent of angle A equals my opposite over my adjacent. Well, we talked about if you're looking for an angle, what do we do on the calculator?
Tangent negative 1.
So that's the second tangent. Alright, so we get 38.68029. I forgot what I said.
38,68029.
Okay. But I said degrees and minutes, didn't I? So that would be 38 degrees. You take your decimal times 60 to get your minutes. So if I take 0.68029 times 60. How many significant digits did we have in the problem? 3. So 38, that's already 2. This is 40.8. Can I call it 41? No, because that would be 4 significant digits. So we'll just have to say 38 degrees, 40 minutes.
So does it make much of a difference that we're only using like 1, 2, 3, 4, 5 digits after the decimal?
That's enough. If you only use like 1 or 2, it'll throw you off.
Okay, so is there like a requirement?
Not really. If you want to use them all, that'll be the best.
Okay.
Since I know we're rounding to the nearest 10 degrees, I didn't
That
think
sounds
we need to
good.
take that many.
So A is 38.
Mm-hmm.
So will we only, use like the significant figures like that since there's 3 and 1 to 2, we only do that to the sides?
Well, we rounded this to 3 because we have the 3 and the 4 counts as 1. But we couldn't call it 41 because that would be more significant digits than we were given.
Or 41 is 50.
Okay, so how could I get, tell me 2 different ways I could get angle B.
Subtraction.
Okay, I could do tangent from angle B and do the same thing, or we could subtract. Do you guys have a preference?
Subtraction's easy.
Subtraction's easy, okay. So we just need to do 90 minus the 3840. So this would be 89 degrees, 60 minutes. So 89 minus 38.
51.
So would it? I don't know.
No, what were you saying?
Like, I know you said like that we should probably use like what's given to us in the problem. Is there one that you would prefer in this situation, or do you?
It doesn't really matter.
Okay.
Like I said, most of the time, probably 80% of the time, you'll get the same answer no matter what. There is a potential that one decimal could be different. So as long as I have the work to know why you got that, it's okay. How would I get side C?
Pythagorean theorem.
Yeah, we could do Pythagorean theorem. We could do a trig function now that we have angles. Let's just go with Pythagorean theorem. A squared plus B squared. You don't have to erase. It's not wrong.
I know. Well, I was gonna scribble it out, but then I heard your voice in my head say, "Don't scribble it." No,
That's exactly what I found.
that's not what you sound like in my head. That's just how I portray you.
Okay, so to get C, we do the square root of this. We want 3 significant digits, so you get 4.36818. So we would have to say, did we have? I didn't give you any units. All right. Do we need another problem like this, where you are given 2 sides and you have to find angles? No?
I'm confident.
So what I want to do is have you write down one more definition. We'll do an example or 2 from it, and then we will stop for today. We're not done with the section, but we'll pick it back up tomorrow. So you need to get this written down, angles of elevation and depression. I mean, those are angles, but the key, both of them are measured from a horizontal line. So elevation is from a horizontal line going up. Depression is from a horizontal line going down. Okay, so let's try at least one before I end for the day. So, the angle of depression from the top of a tree to a point on the ground, 15.5 meters from the base of the tree is 60.4 degrees. Find the height of the tree. What should we do?
Draw a picture.
Draw a picture. This doesn't make much sense. We're just looking at the words.
I'm drawing such a beautiful tree.
So, I have a tree, and I am quite the artist.
That's exactly what my tree looks like.
So, if we're starting at the top of our tree,
I love my tree.
angle of depression requires a horizontal line. So, if we are at the top of the tree, we need to think about a horizontal line at the top of this tree. Pretend that's horizontal. Okay. So, the angle of depression from the top of the tree to a point on the ground, 15.5 meters from the base of the tree. So, I know that this distance is 15.5 meters. And the angle from here going down. Okay, so if I drew the angle is from the horizontal down. That's 60.4 degrees. Okay, so as this is drawn, I don't really have a right triangle, but we could make one pretty easily. If we go from the top of the tree down, can we assume that's a right angle? Okay, so the angle I gave you, is it inside our triangle?
No.
No. But we need to find one inside our triangle.
So subtract.
90 minus 60.4 is
29.6.
It's really windy.
it is windy. I really want the fresh air.
Wait,
but
how does that become the inside?
because you would know a horizontal line and a vertical line
Like imagine
would
you
form
also-
90 degrees. Like the tree, let's assume it's going straight up and a horizontal line, so then make a 90-degree angle.
Got it.
Okay, we want to know the height of the tree, so we are looking for this side. So, what trig function would I use?
Sine.
I don't,
No, tangent, you're right.
so
You're right.
tangent of 29.6 degrees equals the opposite side, 15.5, over the adjacent side x. So then, if you multiply over x, how do we finish it? How many significant digits in this problem? So if I round this to 3, it would be 27.3 meters. Let's go ahead and stop there. Tomorrow I have no new content, but a few more examples. So we'll do another elevation depression example or two, and one just looking at a picture and solving for some missing sides. So I'm going to go ahead and give you the homework. This is the homework for today and tomorrow. So I taught you how to do all of it. Technically you can do it all, but it will not be due until Monday.
When it's written out on the board, it seems like there's so